Okay, for what we have in this lab simulation, okay, we have looking for rank as well as bases for column space and null space. And let's say that we have a given matrix A, okay, which we have to be a 4 by 5. Okay, we have among the elements, you have 2, 4, 6, 0, 5, 7, 9, negative 9, negative 3, negative 4, negative 5, 6, negative 4, negative 3, 2, 5, and where we had the last column to consist of 8, 9, 4, and negative 6. And it says to determine the reduced echelon form, the rank, and bases for both the column and null spaces. All right, now for what we have in this particular case, all right, so we have for the given matrix, okay, now the reduced echelon form, okay, is going to be where we're going to have 1, 0, 0, 0, 0, 1, 0, 0. Third column, we have 1, 6, negative 2/3, 0, 0. And we have 0, 0, 1, and 0. And the last column, we have it 17/12, negative 1, 6, negative 3 halves, and 0. Now, if you notice, okay, we have with the ones, okay, we have to belong in the first, second, and fourth columns. And those will be the pivots, the 3 pivots in the reduced echelon form. And since we have 3 pivots, okay, that is going to be the rank of this matrix. And the dimensions, okay, of the null space will be the difference between the total number of columns in the matrix and the number of pivot columns. Okay, and so we have 2 left over, and okay, so we have so the rank is going to be at 3, and the basis for the column space, okay, we're going to have with the first, second, and fourth columns, which we can use. And again, so we have 2, 4, 6, 0, 5, 7, 9, negative 9. And then we have negative 4, negative 3, 2, and 5. Okay, and that will be a possible basis for the column space in A. Now, for what we have in the case of the null space, if I were to set the matrix multiplied by x and set equal to 0, and again, going with the reduced echelon form, okay, just have adding a column of zeros. So we have the x of 1 will be equal to negative 1/6 of x of 3 minus 17/12 of x of 5. And we have corresponding to the next row, we will have the x of 2 is equal to 2/3 of x of 3 plus 1/6 of x of 5. Now again, there is no pivot in the third column, so x of 3 is free. And we have the last pivot was in the fourth column. Okay, we have the x of 4 is equal to 3 halves of x of 5. And again, no pivot in the fifth column, and thus, like x of 3, x of 5 is free. And on the basis of what we have with the variable solutions, it's going to turn out, okay, that we have in terms of x of 3 and x of 5. Okay, so x, you have x of 1, x of 2, x of 3, x of 4, x of 5. And in terms of what we have with x of 3, so we have corresponding to x of 1, we have negative 1/6. From x of 2, we have 2/3 of x of 3. X of 3 is free, so we insert 1. And there is nothing concerning x of 3 in x of 4 or x of 5, so we have those to be negligible. Now for what we have for x of 5, we have negative 17/12 from x of 1, 1/6 from x of 2. Again, we have 0 since there's nothing in x of 5, okay, for x of 3. And we have 3 halves for what we have corresponding to x of 4, and x of 5 is free, so we can insert 1. And we have for those two vectors, okay, we'll have those to be the basis for the null space of the matrix. And in terms of taking what we have in Maple, all right, and so we have, again, to be able to work, okay, you want to type in with linear algebra. And what I'll do here is go ahead and enter what I have for the matrix. And now what I can do here is that in terms of going ahead and putting in terms of reduced echelon form. So you have row echelon, reduced, okay, so we have this matrix. And also looking for the rank. Okay, so if I look for the rank, and just type in rank, open parenthesis. And again, we have with the matrix. Okay, so the rank is going to be at 3. And as for what we have for the null space, just enter, yeah, combining. Okay, so you have null space, return. Okay, so we have those vectors to return.